We've got a basketball math problem, and Breydan is the star. Breydan was playing basketball. He made 24 baskets and 61 points. He made 2-point shots and 3-point shots. How many 3-point shots did he make? So we're going to solve this first problem with drawing a picture. First, though, I wanted to tell you this assignment is going to be a little bit different. You are going to be graded on your effort, not on if you can do the math perfectly. So I'm going to make the questions more about effort and more about your willingness to try. Okay, so first of all, we know he made 24 baskets. And so this picture has 24 basketballs. It's 3 times 8, it's 24. And if we assume that all of the shots were 2-point shots, then we can figure out how many points that would be worth. 24 times 2 is 48. So 48 would be the number of points he made if all of them are 2-pointers. But he made 61 points. So we know that we need to add some 3-pointers in there. How many 3-pointers? Well, 61 points minus 48 points. So make that a 5, and this an 11, and that a 3. And so we need to add 13 3-pointers here. So let's do that. Okay, there's 13 3-pointers. Now let's double check the math and see if we've done it correctly. Looks like 8, 9, 10, 11 2-pointers is 22, and 13 3-pointers is going to be 39. 22 plus 39, is it correct? 1 there. And carry that one. Got a little bit ahead of myself. So 61 total points. So yeah, so drawing a picture worked really well for this problem. Our next method shows a different problem. Same idea, different problem. So here's 37 baskets and more points. So we know that he had more to do if he made 37 baskets, and that would be a bigger picture, and I don't want to do the picture. I want to do guess and check. So I know that the number of 2-point shots has to, plus the number of 3-point shots, has to equal 37. So just starting with a guess of 20 2-pointers and 17 3-pointers, so I know there's 40 points from 2-pointers and 51 points from 3-pointers. 40 plus 51 is 91. And that guess is low. So change things around and decrease the number of 2-pointers so that I can increase the number of 3-pointers and increase the number of points. So 10 2-pointers would be worth 20 points. 27 3-pointers would be worth 81 points. 20 plus 81 is 101, and that guess is too high. So let's try something in the middle. 15 2-pointers, 22 3-pointers. 15 plus 22 is 37. So that would be 30 points from 2-point shots and 66 points from 3-point shots. 30 plus 66 is 96, and that is correct. Alright, so guess and check does work well. This graphing problem is a little bit different. When he's taking a break from basketball, Breydan enjoys bowling. After how many games would the price be the same? Where should he go if he wants to save money? At what point would bowling at Bowler's Alley and Pins Plus be the same amount? So we're going to write 2 equations that match the prices for each location, then we'll graph the system of equations. And what does the point of intersection mean? Okay, Bowler's Alley is going to be y equals, so we're trying to put this in the form of mx plus b. So the shoe rental is b, it's the y-intercept, it's the one-time cost, and therefore the cost per game is x. So it's 2.5x plus 2, and then Pins Plus is going to be y equals 2x plus 4. So here's our graph. And there's our two equations. Pause the video and set up your graph. The y-axis here is the money. The x-axis is the number of games. So I know that I have a y-intercept for both of them. So the upper equation, y equals 2.5x plus 2. I'll start graphing that one first. I need a point at 2. That's going to be my y-intercept. And I need a point that goes up to 0.5 and over 1. So from 2, I need to go up 2.5, so I'll go to 4, and then I'll go up half again. So this point right here is up. It's up 2.5 and it's over 1. So rise over run. So these points right here, we actually need to be precise when we're doing these points. And I'll show you what I mean. Carefully draw your line so that it goes between both points. But then these big ugly dots right here, they kind of mess me up. So I'm going to use a highlighter so that we can show exactly where we're at here if our line is actually on those points. If you look right at that intersection right there where the line, the diagonal line, it's close to that, the point right there. So I'm going to adjust it just a little and make it better. Alright, so I did my very best to make sure that the line crossed exactly at the point 2 right there and exactly at the point right there where it went up 2.5 and over 1. So that should be 1, 4.5. Now, I want to clear off the annotations on the screen so that it's not such a mess. So we know this line represents the top equation. Now let's put in that second equation. We've got a y-intercept of 4, so that's going to be right there. And then we need to go, here's our y-intercept, and our slope is up 2 over 1. So we need to go up to 6 and over 1. So we should go through this first point that I'm highlighting in red is the y-intercept. That's 4. And then this point here that I'm highlighting in purple is going to be the point for our slope where we went up 2 and over 1. Now we need a line that's going to go right through the center of both of those. Okay, I got that through the center of my purple point. And now to adjust the red point. Okay, now look at where the lines intersect. Here is about where they intersect. So you can see that my graph isn't perfect, but there's a way that we can prove that this graph, even though it's not perfect, is close. In previous videos, I mentioned that you could use Desmos. So I want to put these two equations into Desmos and then see if the point 412 works. So even though this graph here is a little bit sloppy, let's see what happens when we use a math tool. Okay, so there's y equals 2.5 x plus 2 and y equals 2x plus 4. And we have the point right there, 412. If you zoom in on it a little bit, you can see that their work is just more precise than I could be on that Promethean board. But there you go. You've got four games for $12 each. Now it's time to look at substitution. When you solve with substitution, you need two equations first. So Mr. Ames sold, I am helping Breydan in his math story now. Mr. Ames sold tickets for people to see Breydan's basketball game. Tickets for students cost $2.25, and tickets for adults costed $3.50. He sold 132 tickets. So I know 132 is one of my totals, and he raised $368.25. So that's my other total. So I know that this was X, and that's Y. So X for student tickets plus Y for adult tickets equaled 132 total tickets, and then 2.25 times X, the cost of the student tickets, plus 3.5 times Y, the number of adult tickets, equaled that much. So you can swap, you can substitute into either equation. I prefer to use the simpler equation, so I'll change Y equals minus X plus 132. So I used this equation here because it was simpler. And now I'm going to substitute this section here into the other equation. So 2.25x plus 3.5 times negative x plus 132 equals 368.25. I'm going to pause the video as I work the next step, and then you'll see what the difference is here. While I pause the video, I distributed, and then now I need to combine like terms. So I've got 2.25x minus 3.5, and that's going to be negative 1.25x equals, okay, so I need to subtract 462 from both sides. Okay, so I need to do 462 minus 368.25. Keep working that while I pause the video. Okay, I subtracted 462 from both sides, and I got 93.75. Needed to keep it negative because I was subtracting 462 from 368.25, and now I've got a division problem here. So I need to divide by negative 1.25 on both sides. Okay, I know the negatives are going to cancel, so I can do 93.75 divided by 1.25, and that equals 75. So x equals 75. My original equation said that x plus y equals 132. If I know that x equals 75, then I just need to subtract 75 from both sides, and I can get the y value. So 132 minus 75, 2 and 12, 7 and 5, so y equals 57. So 75 student tickets and 57 adult tickets. We can check this with Desmos also. So we found out that the number of student tickets was 75 and the number of adult tickets was 57. So I typed the equations into Desmos, just the exact same ones, and it brought me to the solution 75, 57. So that's my graph. That's what that shows right there. Now our next system of equations method is elimination. Elimination is really pretty awesome. In his best game ever, Breydan made 54 baskets and 123 points. He made 2-point shots and 3-point shots. How many 3-point shots did he make? So what you need to do is come up with two equations. X plus y equals 54, because he made 54 baskets, and 2x plus 3y equals 123. Alright, so the first step was to multiply by negative 2 for the lower equation. In step 2, it shows that that's eliminated. In step 3, y equals 15. In step 4, I figured out that x equals 39.